Good morning. It's my pleasure to welcome you all in MSc final class and also heartily congratulations to all of you for the new academic session 2020-21. I will teach sixth paper, that is nuclear physics and particle physics. We will discuss, first of all, we will discuss about the introduction to atomic nucleus. In the 18th century, John Dalton assumed that atoms were the smallest part of the element, identical in mass, while different elements had atoms of different masses. Since the atom is electrically neutral under normal conditions, hence it can be said that atoms are made up of equal number of positive and negative charges. Now, two important questions then arise. Number one, how many electrons were there in atom? And number two, how were the electrons and positive charges arranged in it? The charges arranged in it. The scattering of X-rays showed that the number of electrons in an atom was equal to about half the atomic weight, except that in the atom of hydrogen. Thomson assumed that an atom consists of a sphere of positive electricity of uniform density, throughout of which was distributed an equal and opposite charge in the form of electrons. Thomson's theory came into conflict with the experiment of Rutherford and his collaborators on the scattering of alpha particles. As you know, alpha particles are doubly ionized helium nuclei, and in this experiment, as you know, alpha particles are allowed to incident on a thin film of gold. And Rutherford observed that most of the particles, they are scattered in various directions, but a very few particles, and mostly one or two particles, were returned back. And this was a very interesting phenomena for Rutherford. So Rutherford, with the help of scattering of alpha particles, well-known experiment, concluded that the atom did not consist of a uniform sphere of positive electrification as supposed by Thomson, but that the positive charges was concentrated in a small region called the nucleus at the center of the atom. Since the atom as a whole is electrically neutral, so it was assumed that negatively charged electrons must be distributed in space around the nucleus to balance its positive charge, and that due to this the scattering of alpha particles are possible. Also, from this experiment, this alpha particle scattering experiment, Rutherford concluded that these electrons cannot be stationary. If it is so, they will be gradually attracted by the nucleus till ultimately they fall into it. To have a stable atom, the surrounding electrons are supposed to be moving about the nucleus in closed orbits, so that the electrostatic force is balanced by centrifugal force, and this was the beauty of this experiment, which gave a picture of atom, and inside the atom Rutherford discovered a concentrated part of positive charge, which is said to be the nucleus. That's all in today's lecture. In next lecture we will discuss about the properties of nucleus, that is the radius or the size of the nucleus, the density of nucleus, and etc. Thank you for your listening, and thank you for listening this lecture.